Hey there, we're going to continue graphing exponential functions. So in the previous video, we graphed y equals 2 to the x, which is this exponential. When x is 0, we get 1, so the y-intercept is 1. And when x is 1, we get 2, because 2 to the 1 is 1. So now let's say we want to graph, and I'm going to graph it on the same axis, y equals 1/2 to the x. So what will this look like? And so again, now we can do a table of values. So I'm going to have x and y, and we can try the same ones. -2, -1, 0, 1, and 2. And so when I go 1/2 to the x, so that's 1/2 to the -2. Remember, a negative exponent essentially gives you the reciprocal. So this would be then 2 over 1 to the +2, which is 4. So negative makes the inside flip. And when x is -1, I'm going to have 1/2 to the -1, which means this will be 2 over 1 to the positive, using properties of exponents, which gives us 2. And then 1/2 to the 0, any non-zero number to the 0 power is 1. And then 1/2 to the 1 is 1/2. And 1/2 to the second power is 1/4. So when I plot these, so let's see, at 0, we retain the same y-intercept. When x is 0, y is 1. But now let's look at -1 and -2. Notice that when x is -2, we're getting 4, and when x is -1, we're getting 2. So when x is -1, we get, when x is -1, we get 2. And when x is -2, you're going to get -4. So somewhere up there. And when x is 1, now you're getting 1/2. And when x is 2, we're going to be over here at 1/4. So notice that it's essentially a reflection about the y-axis of the 2 to the x graph. So if I can draw it, so this will be what our function will look like. 1/2 to the x. And so notice that using properties of exponents, right, 1/2 is really 2 to the -1, and then to the x. And then again, properties of exponents, when you have power to a power, you multiply the exponent, so you get 2 to the -x. And so essentially this negative means it's a reflection, thinking about transformations of functions. And so similarly, if I wanted to graph, for example, y equals 3 to the x and y equals 3 to the -x, they will look very similar. 3 to the x will be the exponential growth function. And we still have cross at 1. And the difference is that when x is 1, this is going to be 3. So this will be a 0.13. For y equals 3 to the -x, but that's essentially saying 3 to the -1 to the x, which is our 1/3 to the x. So when you have a fraction, something smaller than 1 for your base, that's when you have exponential decay. So it's a decreasing exponential function. So the difference here is that when x is -1, you're going to get 3. So this would be -1, 3 for 1/3 to the x. So that's one way you can think of when the base is a whole number versus when the base is a fraction. So reflections, right? This -x is considered a reflection about the y-axis. And it's a type of transformation. So what are other types of transformations? So say I want to graph, so I'm going to stick with 3 to the x and 2 to the x. But say I want to graph f of x equals 2 to the x, say -1. So what does the -1 outside do? So notice that this will be a vertical shift. So again, let's graph 2 to the x. So if I just graph y equals 2 to the x, that's what this looks like. So my y-intercept is 0, 1, and when x is 1, That will be at point 2. So what will 2x minus 1 look like? So this would be the transformation. So that is a vertical shift. Which way? This is a vertical shift down 1 unit. So when I graph this, I'm essentially going to take my 2 to the x, and everything is going to get shifted down 1 unit. So notice that we had a horizontal asymptote at 0. So when we do minus 1, now my horizontal asymptote is going to be at minus 1, right? 0 minus 1 is minus 1. So this is where my horizontal asymptote is going to be. We had a y-intercept at 0, 1. So plug in 0 for x, you're going to get 2 to the 0, which is 1 minus 1. It is now 0. So notice that the y-intercept moves down 1. And likewise, when x is 1, now you're going to have 2 to the 1 minus 1. So 2 minus 1, which is 1. So my whole graph essentially moved down vertically 1 unit. So that's what our graph will look like for f of x. So this is f of x equals 2 to the x minus 1. So it's a vertical shift. Horizontal shift, you will see it as 2 to the x, maybe minus 1 as the exponent. So that would be a horizontal shift. What about a reflection about the x-axis? So if I want to graph y equals a negative 2 to the x. Then the negative here, right, is outside. And so that means that I'm going to take my parent graph 2 to the x, and everything is going to be a negative. So this essentially reflects this graph around the x-axis, so everything is negative. So horizontal asymptote will still be 0, but now notice our y-intercept, when x is 0, you're going to have negative 2 to the 0. 2 to the 0 is 1, so you're going to get negative 1. So this is now my y-intercept. When x is 1, and you can kind of plug them in here, x and y. When x is 0, you get negative 1. When x is 1, you're going to get negative 2 to the 1, which is negative 2. So it's going to be down here. And then, so you're essentially just really flipping the graph. So this will be negative 2 to the x. So those are some of the kinds of reflections that you may see. Mostly, we're going to be working with vertical shifts and some reflections. For if you want to do y equals 2 to the x minus 1, then we can look at how is this a horizontal shift. So I encourage you to look at this one. What does the graph of this function look? What does it look like? Sorry. So graph on your own. In the next video, I'm going to cover the applications of exponential. So we're going to do some compound interest.